Let's take a look at how to get graphs of logarithmic functions. One possible way is to use its corresponding exponential function. And so for problem 1, if we want to graph g of x, which is log base 2 of x, I may want to start with graphing f of x, which is 2 to the x. Okay, so to do that, the first thing that we would know is the y-intercept is a 1, because we can rewrite 2 to the x as 1 times 2 to the x. So I'd have a point at 0, 1, and then I could find another point like 1, 2, or 2, 4, or 3, 8, etc. And what happens with exponential functions is that they should have a horizontal asymptote. So this imaginary line that the graph approaches, in this case it's the x-axis. We can see that the domain of this function is from -infinity to infinity, but the range is not all real numbers. The y values are always positive, and so we're going to say the range is from 0 to infinity. So then if we want to graph g of x, or log base 2 of x, we can just kind of flip this graph across this line, y equals x. So each of these points, the ordered pairs, also flip. And so an ordered pair of 0, 1 on the graph of the initial function becomes a point 1, 0 on the graph of the logarithmic, etc. And so connect those points. You should see a logarithmic function that looks something like this. Now, the domain of this logarithmic function is not all real numbers. It's really only positive numbers, and so we're going to say from 0 to infinity, and the range is all real numbers, so -infinity to infinity. The coordinates of the points flip-flopped, the domain and ranges also flip around, and so the domain of this exponential function became the range of the logarithmic, and vice versa. For number 2, what if I wanted to graph m of x, which is an exponential function that's related to n of x, this logarithmic function, log base 1/3 of x. One thing we can do is write the equation of this exponential function. It has the same base, which is 1/3. So m of x equals 1/3 to the x, and then sketch the graph of this function, and then sketch the logarithmic function. But we'll see that it's not really necessary to sketch the exponential function if it's not required. So one thing that I would do is just rewrite n of x, just call it y, and rewrite this equation in exponential form. So we get 1/3 to the y is equal to x. And then you can make a table of values where you're going to select y coordinates. So you're going to start here first. And so say we choose -1, 0, and 1, but you can pick any y. I do want to pick some that are on my given grid. And then substitute those y values into this equation. So 1/3 to the -1st is 3. 1/3 to the 0 power is 1, and 1/3 to the first is 1/3. And now we have 3 ordered pairs that are going to fall on the logarithmic function, and so I would just graph them and recognize that this graph is going to have a vertical asymptote on the y-axis. And it looks something like this. And so the domain, again, for this function, like the last one, is 0 to infinity. And the range, like all logarithmic functions, is -infinity to infinity. We can then graph the exponential function pretty easily by taking these ordered pairs and interchange the x and y coordinates, and we get some points on this exponential function. So 3, -1 becomes -1, 3 on the exponential. 1, 0 becomes 0, 1. And then 1/3, 1 becomes 1, 1/3. And the last set of functions that we want to graph is p of x equals 3 times 2 to the x, and q of x, which is the corresponding logarithmic function. This is not quite so obvious what this new function will be. So let's first rewrite the given function as y equals 3 times 2 to the x and isolate the power. So we'll divide both sides by 3 and then rewrite it in logarithmic form. But remember, these inverse functions have the x and y interchanged, and so we're just going to flip-flop those around, and we get q of x equals log base 2 of x over 3. Okay, so this time I'm going to graph the exponential function first, recognizing that the y-intercept is 3. And if I substitute -1 for x, that's 3 times 2 to the -1st, or 3 times a half, which is 3/2, or 1.5. Okay, and then if I substitute 1 in, that's 3 times 2 to the 1st, or 3 times 2, so 6. And now I have some points that we can plot. -1, 1.5, 0, 3, and then 1, 6. And connect those with a curve. And then we can reflect that graph across this line, y equals x, to determine the graph of q of x, the logarithm.